Hi all. Yeah, it was last week. Last week I didn't do because it was Christmas, obviously. My wife's birthday on the Sunday. So yeah, I'm just setting up the links to copy to Facebook. Here we go. Right, we are connected. Let me get back to the stream so I can see what people are typing. Happy New Year, Happy Christmas, obviously as well. Hope you had a nice break. Hey Lee, Tony, Richard, Matteo, and Stuart, welcome back. It's 2 weeks since the last one, so that's why I'm doing another one today, even though I'm running a bit late. And just getting my mouse back from C-Spect. Matt isn't going to be here today, so I'll have to try and keep an eye on the live chat stream. Right. As the couple of things that I was wanting to start going on with, which is the include file stuff in Odin. As that's not quite ready yet because Matt's been a bit busy with the family stuff, obviously, because it's been Christmas. We will just continue with the last one. So we go into .odin and then load our plot test.ods. Has everyone still got the plot test.ods? Right, and if you remember, assemble it and run it, and we have that. So you can just move around and space quits. Run it again. So you can draw stuff. Right, now, as it's New Year and things have been busy, we'll just have a shortish one this month, this week. And no, F10 to swap over to game mode. Right. Right. What we're going to do is we're going to go to the end. Actually, what I will need to do is add a font, and I will just upload that font to Facebook and send a link. Files, upload file. Where I'll use font.jar. tutorial. Which tutorial is it? 8 or 9? Number 9. Tutorial 9. Right. I just posted on the group a link. If I can get a link. Post. Copy link. Let me just put it in the chat. There you go. Can people get that file? To go in and out of the editor is Shift and 1. But make sure you press F10 and go in game mode, because otherwise Shift F1 in basic mode will give you exclamation mark. You haven't missed much, Retro Robins. I started a bit late. I've just uploaded a file, as you can see in the live chat, and that is a font which we will be including ink and then spec font dot jar. Right. Let me just save this and exit out, because I'm going to need to add it to the image, the file image. Right, let me just check if I've. Yeah, that's assembled. Okay. Does everyone remember how to add it to CSpec, or add it to your SD card on your Next if you're using it, doing this on your Next? Lee, I don't know. Has it not been shared properly? It should be there. It's on allow everyone to see it, so the post should be there, Lee. Let me know when you get it. Yeah, you got it in place. Cool, Stuart. Yep. That's where you're supposed to get it from. Have you got it yet, Lee? Cool. Downloaded. And have you got it to your everyone got it included in the file with the font Inkbin spec font and spec fonts.jar in quotes. Lee Hearn, waiting on your reply. No, I don't have a Facebook account anymore. Right. Okay. Can. Hang on. Hold on, let me just message you and send you the file directly. There you go. It should be winging its way to you any moment now. Right. Have you got it, Lee? Put it in the root folder in the on the SD card. In the root, yeah. Yep, you got it. So has everyone typed in the font ink bin spec font.jar in quotes, the spec font.jar? Are we ready to continue? Everyone ready to go on the next bit? Yep, cool. Retro Robbins. Give Lee a bit of time to catch up. Shall I drink my tea? I'll wait. Thank you, Matteo. I need to be caught up, Lee. And if anyone's using CSpec, then hey Crowley and Mike, obviously. Yes, Lee, someone Matteo's already shared the file anyway. You'll probably get that in a couple of seconds. Right, oh god, right, okay, cool. Oh, I'm sort of typing the right window. Right, now, if we scroll up to the we don't want to, yeah, after, well, just before plot. Print routine. Take on D equals position, HL equals message. Right. And we'll also be adding a oops, if I can type print character D equals position, A equals character. Right, and then char Shift 3 gives you a tab. Yes, Matteo, you was the fastest with copying the file to another site. Well done, and thank you for your help. Right, print jar. We will do push HL because we want to use HL to point to the font. So we'll do load. Right, doing capital C, yeah. Load L, comma A, load H, comma 0. Right, if you remember last week we got HL as a 16-bit register, but it's actually mixed of two 8-bit registers, H and L. So what we're doing is we're copying the 8-bit register of A into L, and then setting the H, which is the high byte. H and L is low and high. So L for low, H for high is, I usually remember it. Setting the high byte to 0. So what we've got now is if I put the comments in while we're doing it, it might be even better as well. Sort of, how would you say add this in BASIC? There's no real push and pop in BASIC. So this really, is that how you spell it? Brain's gone to mush today. Temp storage of HL register to stack pointer. Right, and it's with push and pop. What it does is it pushes a 16-bit value to the stack, which is the SP register, and it then decreases. Well, it goes back a byte, puts the high byte, goes back a byte, and gets puts the low byte on SP in memory, and then when you pop, it gets the low byte, increases SP, gets the high byte, and increases the SP. SP being the stack pointer. Right, this one is let L equal A, and this one is let H equal 0, or then both together is let HL equal A. And don't forget, A can only be from 0 to 255, and so can L, and so can H, but HL is 0 to 65535. Right, now, because the font that we've got is a 1-bit font, like the original Specky font, its 1 byte is 8 pixels. So for an 8x8 pixel image for each character, there's it's 8 bytes. So you want to times it HL by 8. So what we do is we add HL, comma HL, and this does let HL equal HL plus HL, which in other words is let HL equal HL times 2. And we want to do that twice. Copy that, which is Control Shift or extended mode, or symbol shift and caps shift, and then D for duplicate line in Odin. and that will give you temporary. Yeah, thank you, Tony. And you just saw that. Yeah, it's putting HL on stack basically, Stuart, so we can retrieve it for later when before we return back from print char. And the reason being is our print routine has HL stored for the pointer to where the message is, and we don't want to corrupt HL. Otherwise, it'll just point to random things. That'll be pointing to the character, the data for the character that you've just drawn. It'll be the character after, the first byte of the character after. Is it better than shift? Yes, you can, but I'm doing it sort of this way, so you can. It's easier. Just to give you an idea of what thing, and it'll also help if you're looking through other disassemblies of old games. You might see things like this. If instead of doing the new instructions all the time. Anyway, so this one is after the first one, it's ×2, but because we're doing it more than once, that then becomes ×4, and then this is then ×8, because the first one's times by 2, then times it by 2 again, so it's ×4, and then times it by 2 again, so it's ×8. And then we do add HL, font. And did I call it font with the lowercase? I think I did. I'll just check. Yeah, font. Right. And that, there is something I need to do, which I'm surprised no one's told me yet. No one's reminded me. And no one's even pointed out there's a flaw in it already. Let's see who's the first to know. Not you, though, Mike, because I know you'll know this one. Add font base address to HL to point to font. Crowley can't join in either with this one, this challenge. All right, I'm gonna do this, and then we're gonna print the character. I'm not gonna fix the issue, and let's see who finds it and find out how to fix it. Right, then we do. Should I have done? Actually, I will do push DE and then pixel add and then exd HL and then actually that's enough there. Right, because what we want to do is get the pixel address in HL. Temp storage of DE register, which is position. Right, and then well spotted, Richard. Point for Richard for getting that one. We shall do it now. Yeah, basically the characters start, the font starts at space, which is character 32. So we need a sub 32 there. Right, convert the pixel quad DE to screen in HL. But how do we explain it right? You can't. Well, you can do this in BASIC, but you need to do a separate register, well, variable. In fact, I will explain DE and HL. Swap the DE and HL registers. Right, and what this does is it's like doing let temp equal DE colon let DE equal HL colon let HL equal temp. And so basically, say you've got your HL and DE. It moves HL to it moves, yeah, I have DE in this hand and HL in that hand. Right, moves that to a temp register, and then moves that one into there, and then moves the temp register into HL. So basically swaps them over. Right. Right. So we've now got a font. And swap the HL and D registers because screen is HL. And we're going to use HL here for the font. So that's why we EXDHL is so we can swap the Pixelad value back to DE, so we can use the HL there. That's why we've pushed HL and DE above. Right, load B, 8. So we now got screen address in HL and the font, screen address in DE, sorry, and the HL is pointing to the font. Load B, 8, and then print PRCHLP, print character loop, load A, brackets DE, HL, which is the first byte of our data. Hang on, let me just put the comment in for let B equal 8. Let A equal peak brackets HL. And then load bracket DE, A, and then pixel down, because we don't know what pixel line it's on. Normally, if you're doing character aligned stuff, it would just be INC D there, and INC HL. Actually, we can't do pixel down on that because pixel down works on HL. Okay. Okay, what we can do is we can EXD, HL and swap it back here. Swap D and HL back. So now HL equals screen, D equals font. Right. So D. Right. Is this still going, by the way? And you can all hear me okay, because everyone's been very quiet on the chat. I'm just making sure that the chat hasn't frozen or the screen hasn't gone black like it did last time. Busy typing. Okay, all good. Right, cool. So you're following. So the load HL with A is not let, it's poke HL comma A. Right. Again, I'm not going to go into the moves HL screen location down 1 pixel. I will go into that at some point, but not in this early version of the tutorials. Right, and then IncDE, because we don't know, we haven't put it on a page align or anything, so we can't just IncE, but because it's faster to do IncE than IncDE. Again, for those who don't know what page aligned is, it's just when you store things at a set like 256 byte boundary, or even an 8 byte boundary, because you'll know that when you do IncE, it'll just increment the low bytes if you know that the it's not going to overlap into the next page, the next 256 byte page. Then yeah, okay, to do an IncE instead of this IncD. So let DE equal DE plus 1. I know, yeah, intense concentration and silence. Keep up the good work. Right, so now we've taken a byte from the font, put it on the screen, move the pixel down, increase to the next bit on the byte, and then all we do is DJNZ PRCH loop. And what this does is let B equal B minus 1, colon, if B equals 0, then go to PRCH loop. No, sorry. If it doesn't equal, Control RT. Control RT or symbol shift R and T for the less than greater than, which is not equal. Right. And then we should be able to simply pop DE, pop HL, load A, E, add A, 8, load E, A, ret, no carry, load E, 0, load A, D, A, 8, load D, A. I'm just going to do ret C here. Well, I'm just going to do a ret here. I'll go through why we're doing it. bring back our old DE value, screen chord, and then bring back our old HL value, whatever it was, because we don't know what called this routine, or it might not always be the print routine. And then load let A equal E, and then let A equal A plus 8. And this is all this is because the A register is the accumulator, which means most of the accumulation goes through the A register for 8-bit stuff. So to add 8, let E equal 8. So to add 8 to the A register, what you do is you have to add 8 to the E register. You have to load it into the A register, add 8, and then put it back into the E register. Right. If A is greater than 255, then it's less than 255, then return. Right, let me just type the rest of these comments in. Does anyone know what that bit is doing, or do I need to explain it? Right, on calling the I should wait for replies, I suppose, because probably won't get the question until a bit in. Still intense concentration and silence from the audience. Right, as no one's answered yet, I will go through into it anyway. Yeah, it's moving our old screen coordinate that was passed into the routine. We're adding 8 to it, because if we do it after it prints a character, it means we don't have to do it every time after it prints a character, because this will do it automatically for us. When it prints a character, it'll change the coordinates. So adds 8, and if it's less than 255, if it's not gone off the edge of the screen, then it'll return back to where it called it. Otherwise, let E equal 0, which puts the pixel coordinate for the X coordinate back to 0, and then let A equal D, let A equal A plus 8, and then let D equal A. Right, now, normally you'd probably get some like system coders saying, oh, why aren't you checking for like extremities, like when because there's only 24 lines or 192 pixels on the screen. So when you if you check where you're going to be drawing, because if you go down and it goes off for the wrapping, and it goes off the bottom of the screen, it'll start corrupting memory. It'll start corrupting the attributes, and then into some of the system variables and stuff, and could cause crashes. But if you know what you're doing and you know that you're not going to print there, then you don't need to do the checks, and it keeps code fast. Otherwise, you end up adding a load of checks to see whether you're printing off screen and etc. etc. And then it slows things down. So as we know we're not going to be printing off screen, I'm not going to do it. Right, then return, which is basically returns to whatever called it. Right. So has everyone got that? Sorry, I missed what you typed, Richard. Has everyone got the print char typed in? I'll just pause it on here for a bit so people can see. So if you want to pause when you're watching back, type it in, and the last bit there. I'll give you a little pause so you can see that's the full extent of the print char routine. And now we'll go on to do print. Right. Load a comma brackets HL. Ink HL. Or a red Z. Right. Let A equal peak HL. Let HL equal HL plus 1. Or A is a quick version of doing compare 0. So if A equals 0, well, actually this is if this is the bit that says equals 0, then return. Right, so we'll have our text message terminating with a byte of 0. Then compare 32. If A and then JRC comma PR code. If A sorry, if A is less than 32, then go to PR code. Otherwise, call print char. Call it print char. Yeah. Go sub PRT CHAR, and then jump print. Go to print. All right, so just finish off typing the rest of the stuff. We have the PR code. So, can anyone tell me what this one's going to be? These are print codes inside the text message. And the reason I'm doing it is these numbers is it's what you use in BASIC as well. You can use in BASIC. If you use the RST16 when you're printing characters, if you're using a basic print. Yeah, that's right, Richard. RETC is returns if carry is set, and NC returns if carry is not set. So what it basically does is it does like a pretend subtract 32, and if the carry is set, in other words, if it's gone less than 0, then the carry is set, and so if it's greater than 0, it'll be no carry, because the carry won't be set because you won't have gone through. It won't have wrapped around 0. But not carried round. Right. Yeah. No worries, John. Yeah, that's why I want to do the basic version in the comments after the code, because that way you remember easier. And so when it comes to you're actually doing stuff yourself, you'll be able to look back and say, oh yes, it's jump carry if it's or return carry or whatever. Right. Anyway, the character of 22 equal if a and then JR NZ, not Pratt. So if does not equal 22, then go to not Pratt. I don't know if I can. Yeah, I can just about get that with a space. It's basically not print at. So this is print at. Print at code, and this will be load E, bracket HL. Let E equal peak brackets HL, inc HL, let's HL equal HL plus 1, load D, brackets HL, let's D equal peak bracket HL. Although I think basic uses the other way around. I think basic grabs the Y first before the X. Inc HL and then jump print. Let HL equal HL plus 1. Go to print. So I'll continue the print routine. And then I think we'll leave it here for now. With this, we'll just jump back to print. Doesn't need to no more codes. So jump back to print. Right. Now there's one more, which is a little thing that sprint routine, which I used to use a lot back in the day because it saved bytes setting up, and what it also confuses disassemblers. And what you do is helps to put the label in. Sprint pop HL. Get the return address from stack into HL. Call print, and then jump, tick channel, then call print, then a call to go sub in basic, and then there's no conversion of this, but it's basically go to code at HL. You can't have less than 32 code, but further down, yeah, if it's less than 32, then go to PR code. The PR code is here. So it's less than 32, so compare with 32, Gamerise. Comments is, yeah, NZ not equal. Z is equal and NZ is not equal. Why is this not less than 22? No, the compare basically does well, compares to see if then depending on the carry flag and the Z flag and the parity and the negative and the minus bit, and what's the other one? The overflow. But we're only dealing with carry and no carry and JRZ and NZ at the moment. So here we have that if it's less than 32, it means it's a character code. Well, it's a print code, so you're going to be doing checks to see if you've got a special byte in the text that you're trying to print. Otherwise, it'll just print the character. If it's like anything above 32, well, anything 32 or above, it'll print character and then go back to the print loop. Otherwise, if it's less than 32, it'll come to here and then it says do a compare with 22, which is a special code for print at. In fact, I will change this in a minute and we'll do it as a define. So if it's not print at, then if it's not the print at value of 22, then it'll jump to print at, which is, there's no more codes here, so we just do jump print. Otherwise, if it is 22, then it'll get the next byte and put it in E, and the next byte and put it in D. So we get our new coordinates for the print at, and then it goes back to print. Has that cleared it up a little, Gamerise? Right, I'll wait for you to reply. Christian Losek, you can use add HL, font. It's the Spectrum Next. We have that instruction. We also have add DE, address and add BC, address. We just thought it was easier than having to push and pop register and add. No, instead of doing push DE, load DE, font, add HL, DE, pop DE. We thought that add HL, font would be helpful. Yeah, okay. Gamerise, glad you got that sorted. I mean, yeah, we could have used BC, add BC, load BC, font, add BC, HL, because we haven't actually used BC yet. But anyway, so we've now got our sprint routine. which will pop the return address from the stack, which is the instruction right after the bit that does call sprint. And I'll show you what I'll show you that in action. So at the top of our code, we can do call sprint db 22 comma 8 comma 8 comma quotes hello world. Oh, what is exclamation mark? I'll press it on. Cheat. And press F10. Right, it's symbol shift 1, isn't it? Exclamation mark. Right. And then comma 0. And that is all we have to do for our print routine. We don't have to set up where the data is, because it pops it from the stack, pops its return address, which would normally be the start here. Return address would be this first byte, which is 22. But because we pop that into HL and use that to call print, and then print will return with HL being, it'll print all these characters, and then after the 0 it'll return, but after increasing HL, and when it returns it jumps to HL, so it jumps to the instruction after, so which will be our nreg. So if we save this, open how this works, because it's, I recognize that format from alternated strings and say, yeah, well done, Stuart. It's basic mode. Right. So assemble and then run. And then we have hello world. And it's at 88 pixels. Right. Now we can do it at 2 pixels down. In fact, we can duplicate it and print it at 8 and 2, but we'll put the other ones further over. Oh, save that and exit. Game mode. There you go. And run. Why has that not worked? Ah, that was silly. Copy that line and paste. You needed 2 sprints. Yep, no worries, like. So now, hopefully that didn't do anything silly with the instructions not being, yeah. And it hopefully hasn't trashed the file. Right, so if I quit this out, because it probably did something. Odin load test.ods. Right. What line is that in? 56. Ah. Right. Save. Again. Right, so we've got two. And as you can see, they are offset. In fact, what I will do is put that 0, and then copy that, and then paste it twice, copy that, and then paste it there and there. Right. In fact, we don't even need to do that because wrong one. X is delete. We just need to just remove these zeros on the end because we've not finished printing. Put that DB0 there. Right. 128 and 192, and then that's 2, 4, 6. Save that. Did that not save? Yeah. As you can see, it goes down 2 pixel lines each one. And on the right, over here, it's gone to the next line. The RLD, because it went over to 256 when we printed. Right. Yeah. Add HL, value is accepted. It is a brand new next instruction. Well, not brand new, we've had it a while, but yeah, it's new. It's a Z80N instruction. Specifically added to the next. Right, so now that we know we can do this and print it anywhere. Right, what I would like to do now to make it print a different color, right? What you'd have to do is make attributes, or make it set the attribute, and to do that, you would have to after the print routine, you would need to, I might as well do it because then we can add color to it. Right, now we've got HL being in a screen coordinate, and we have to change the screen coordinate to a pixel coordinate, to an attribute coordinate. And it's been a while since I've done this. So we don't need to change L because L already, if you look at the way a ULA screen loads, it loads the first 25 bytes, or the low byte of the address, is like the attribute. So you want to get all we need is the Y position. Well, it's there's certain bits, right? I'm gonna have to put a. In fact, I will write it up here actually. Right. To attributes. Right. Now, so for basically, you want string 4000 to be string 58 and string 48. Is it 58? Yeah, 58. And string 48 to be string 59 and string 50 to be to equal string 58, string 48 to equal string 59 and string 50 to equal string 5a. Right, and if you remember, the screen's laid out in thirds. Top third is string 4000 to string 47ff. Right, they're all valid addresses in the top third of the screen. And attributes equals string 5800 to string 58ff. Mid third is string 48 to string 4fff. Address equals string 5900 to string 59ff. And bottom third is string 500 to string 57ff. Attributes are string 5800 to string 58ff. Right, so what we need to do is let me just, so it's 0, 1, and then 0, 0, 0, and 0, 0, 0. Right. Y char and what pixel. Right, so the screen, that's the high byte, and then so and then the low byte is whatever it is. But as we're just doing the third, the low byte stays the same. We don't need to worry about that when we convert from screen to coordinates. And what it needs to equal needs to be So 5800, so it's 101 is the 5, and then 800 is 1000, and then the last 8 bits aren't needed, and then it needs to be 8, 9, and A. So it's that is the first one, first line of the top third of the attributes, the middle third, and then the bottom third. Right. So A with H and 1 1 1 0 0 0 RRA 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 or string 58 load H comma A. I'm going to do it this way because what I normally do is db62, which is A comma N, and then have attribute db7. So it's load A comma 7. Right. But what we're going to do is, so you know what it's doing. So I'll get rid of those 2 lines. Right. HL comma A. Right. Let's A equal H. Let's A equal A, and it's a logic and or bit and. Now RRA, it rotates right the A register. So where we currently have it's not really it's divide to, but because they are integers, we don't have 1 equal and a half after it. It's just 0, and the bit in carry gets set. So right, so we've got it basically rotates the bits right. A by 2, and again right. So if, say for example, A equals say all 101 and then 0 0 0, this would then be A would equal, after this instruction it would be 0 1 0 1 0 0, and then A equals 0 0 1 0 1, and then this last one would be A equals 0 0 0 1 0 1. So it's basically rotated the bits positions to the right. Let A equal A or string 58. That's base action to A. Base of the high byte, which is 5800. And let H equal A. And then we get the attribute. And then A. I don't need the attributes, do I? The brackets. Right. Now, if we attribute db 7. Right. The reason I do that as a db62, which is a load A comma the next byte, is it only takes 2 bytes, whereas this version takes 4, and it also takes longer because it doesn't take just 7 to do the load A comma 7. It doesn't take 70 states, it takes 13 to do that, so it's actually slower as well doing it that way. But for simplicity, we're doing it this way. Yes, it does, but the RRA does, but when we do this and here, that also clears the carry flag, so it doesn't bring in any junk. And because we've done an and, only those 3 bits are set and the carry is set. So when we do it and rotate it 3 times, it only rotates 3 times, doesn't bring in anything because the carry's not fallen. There's been nothing in these bits to carry round. So I suppose rotate right, it puts the bit, what was in bit 0 into the carry, and whatever the carry into bit 7. So it's a bit more than let A equal A divided by 2. It's plus bracket old carry times 128. I can't put any more in, but yeah, we'll get to that at another time. But what it does is it rotates you got your 8 bits. It'll rotate them. You're looking at the other. Hang on. You can see this on the right of the screen. So it'll when you do rotate right, this bit goes into the carry. They'll move across one, and then whatever was in carry before this bit got put in will get put over here in the high bit. And the RLA is exactly the same, only it rotates the other way, rotates left. Yes, so 9 bits, unless you use the RRCA and RLCA, which sort of ignores the carry bit. So the bit 0 goes back into bit 7, or bit 7 goes into 0, whichever way you're rotating. Yes, there's 9 bits involved with RRA and RLA. Right. So now that we have attributes, go back up to my print routine. We can add print codes, add more print codes, right? And that will be compare 16 if A JR NZ comma not print. Not equal 16, then go to not print. Not print. And then we want to do load A comma brackets HL load bracket comma A. We call it attribute ATTR. Yeah. Do it to the HL there. And then jump print. And the reason I've got two jump prints here is because if we add another instruction, we don't want this falling through to do a compare on the next instruction. That's why we've got two jump prints, just in case anyone says, why have you got two jump prints? You don't need it because it's going to jump print anyway. And yes, if we did that, it'll fall into it. But it's in case we add anything else, which we will be doing in a bit. Right, so in our, let's back up the top of that. Is there anyone? Yeah. Is anyone missing a bit of what we added, or is everyone up to date? Where did we put our code? In the call, isn't it? In the sprint call, yeah. Right. And then we could do comma 16 comma actually we want 56 plus plus 1, and that is actually, I should probably do it 7 times 8 plus 1. And the reason for that is this 56 is 7 times 8, and that is the paper color. And because we start off with white paper, color 7, and so this should be blue writing. And if we duplicate that line, we should put it on the next line down. We should be able to have it in red, and then duplicate that. Save that, and there we go. You have colors. So if we wanted to, just putting spaces in there to keep it nice and neat, we could have had that in 4 and 6. So that'll be magenta and paper and yellow paper. So save that, and A and R. No, it's green, sorry. 4 is green, not magenta. 3 is magenta. So has everyone got green and yellow paper and blue and red text? Everyone up to date? Anyone missing? Not anyone not keep up and need to catch up with anything, or are we good? All right, okay. In your sprint, Stuart Guest, is that right? Have you got your DB0? You probably need to exit out if it's crashed, if it's done something like, and then load it in again. So exit CSpec, then load it in again. Right, so that is correct. So it's not that. So if we go down to our, so did it work before with the hello world before we added the color? Right, okay, so it worked before. So the only bits changed was we added this bit. Have you got CP16, JLNZ, not prink, and then load A, comma, bracket HL, inc HL, load bracket attributes, comma array. Have you got all that? Oh, while you're checking that, I'll just do the comments. HL equal HL plus 1. Right. Poke attribute, comma A. Go to print. Looks okay so far. Cool. So it must be in the did you have the EX? You had the XDL stuff in, so it'll be from this bit here. So to do attributes bit, which is up to there. So is that correct? There we go, Stuart. It's load A with H and sent 001110000, then RRA, RRA, RRA 3 times, and then or string 58. I mistyped one number. Which one? The string 58 or the and? Load H with A, load A with attribute, load HL with A. Yeah, or 5A. Yeah, that's where it's going to be writing the attribute. So you're gonna need that to be correct. Actually, because there's only thirds, it should be that actually. Because you're not going to get a third that's there isn't 8 thirds, so we can get away with, and not that it'll matter because you're never going to be drawing it at the so we'll put it like that because you want it to be just in the thirds anyway, so let's save that. So colours are working, cool. Right, everyone else got the colours working, and don't forget to change the and to these are the thirds that they're in, not characters. Hang on. Nope. 4,000. 4,000. And it's that. I know it's definitely. Yeah, it's just that. It is that. 4,800. It's, yeah. Thirds is not 8. That is the pixel. It's not chart, it's third. And then 0. That's it. It was 5/8. That was right. That's 5/8. Plus third. My third is only 2 bits. Right. And X pixel is 3 bits. Yeah. So that's the 4, and that goes into the 5 for the bottom third, and then that's the pixel. The character is in the top third character. The first 8 character lines are in the L address, but as that carries on into the attributes, it's fine. So you don't need to worry about that. So hopefully now, just to clarify, it is screen address is 010 and then the XX and then TT for third and then PPP and then if we go into the low byte, it will be character, and then exposition. Right. I'll put that as a slash because there's a comma. That is the high byte of the screen position is 010, and then depending on which stage you want, and then which pixel you want, Y pixel, then which Y character in the low byte, the top 3 bits of the low byte, and then the bottom 5 bits are the exposition. Now, new here. Oh, hey Jim, Crosskull. What is the dev tool using? And is it running on Spectrum Next or PC? Well, I'm using CSpect, which is a Spectrum emulator, well, Spectrum Next emulator on PC, but the actual tool is Odin, and it is an assembler that runs on the Next, which is running in CSpect because it's emulating a Spectrum Next. So Odin will actually run on the machine as well. Have you just joined now, or are you up to date with anything, or is this the first one? Because we're like 9 parts in, and each video is about 2 hours long if you cut off the end bits where we gab and stuff. How much Z80 do you know? Do you know much of it, or? Just joined now, right? Okay, cool. What I would suggest, how busy are you over the next 2 weeks? Because I would suggest that you follow the tutorials from part 1, and that'll go into CSpect and downloading it, and I dabbled a bit over the years, cool. So you should be able to catch up. So if you're not busy over the next 2 weeks, can I give you some homework and ask you to watch the other videos, part 1 to 9, well, including this one, 9. Shielding at home, excellent. Stay safe, obviously, and enjoy catching up with the Next. And hopefully in 2 weeks, because I do this every 2 weeks roughly. In 2 weeks, hopefully you'll be up to date and you'll be able to carry on and join along with us, rather than like coming in like midway, because we've gone through a lot. So it's great that you've joined, but I would say it would be best for you to go back to the beginning and catch up, just because there's a lot, but we have covered everything, and you will should be good to go. Excellent. Well, the links, I'm still there, Mr. Crosskull. Oh, the links, yeah. The links files are still there. Download. There was an issue with the assembler in the first video, but obviously when you download it, you won't get the issues that we have in the bugs that we have in the first tutorial or the second tutorial. And when we start using Odin, so you can skip that bit. So sort of fast forward bits till we fix the issue, or basically jump to the end of that session. Unless you want to watch through, because it shows it does go through debugging and trying to find out what is going on, where and why things are happening. So yeah, it's interesting if you are into that kind of thing, but it also could be helpful moving forward when you come to do your own stuff. Anyway, back to where we were. So we now have our color in the attributes. So what I want to do now is because all we've got is printing text, right? When you do a game, you usually want to print things like a score. So what we can do is we can add another code. CP what should we do this one as, since there isn't on that thingy? 12. If A KRN NZ, comma not CLS. We'll do a clear screen as well, just for the hell of it. And go to not CLS. Push HL. Load HL string. Load DE string 401. Load BC comment string 1800. Load bracket HL. I would do comma 0, but because L is already 0, I can do a load HL with there, and LDIR does a block copy from HL to DE and puts and does it 1800 BC bytes long. And then we do load BC comma string 2FF, not 300, 2FF, because we don't want to write over the end byte of the screen. A comma bracket attribute load bracket HL comma A LDIR. Right, pop HL as well, and load D comma 0, because we've cleared the screen. We want to set a coordinate to the top. Right, store HL on stack. Let's HL equal string 4000 screen address. Let DE equal string 1. Next byte of screen address. Let BC. Just so you know, Jim, what I'm doing when we get to the assembly bits of the tutorial, I do a rough translation of what it would be in BASIC. I mean, there's no push HL. It's a bit more complicated, but just giving you an idea of what it's actually doing. So if you know BASIC, because a lot of people who follow along with this know a bit of BASIC, so it helps them helps people who know BASIC understand machine the translation, the crossover to machine code. If you sort of get a grasp of what the instructions do, then you know that you can start experimenting yourself. Right, because it's HL comma because we're copying from 4000 to 4001, when it increases, when the LDIR does the next loop, actually, it's because we're doing from there to there. When it finishes this, HL will point to 5800, which will be the start of the attributes, which is why we do one less when we do here. Because if we were just clearing the screen, it would normally be 17FF. But because we want to go into the attributes, it does actually set the first attribute byte to 0 for like a couple of milliseconds or microseconds even. Well, it does the load BC with 2FF and load A with attributes, and then it'll fix the top left attribute. Let BC equal string 2FF 767. Because there's 768 bytes of attributes. Let A equal peak attribute. Poke HL, comma A. No, that just sets the first byte of the attributes. So this LDIR, which is a block move again, block move BC bytes from HL to DE. Right, and then restore HL because we didn't know what it was before and we don't want to mess it up, and because that's what we're using for our print routine. And then set chord to top left 0. Let DE equal 0. And at some point, I'm going to have to go easy on the comments, or mind you, probably, hopefully the include will be sorted by next week, by 2 weeks from now, and then we'll be able to split this up into different routines, well, different files, and that way we know that we're not going to fill up, not go over a bank of memory, go over a 16K bank. Is character string 14? It's character. Is it character 14? I thought it was 12. It could be 14. Not that it matters because it's just values. In fact, what I will do is because I meant to do this before to make it easier. Codes. Uh, 16 PLCLS. Right. So we could change this to, if we change this to CP PREOF, then that way we can have, if we wanted to, we could have it end with FF or 0. Yeah. And then PRINK. CLS. Right. If it is 14, I can't remember. I shall have a look if I don't wreck the manual. It's in the back of the manual. Clear window 14, 12's backspace. You're right. You're very, very right. So anyway, now that we've got an equate defined for it, it should be very simple. Thank you for that, Matteo. It's 14. Right. Now, what we need to do is we can do PR. In fact, we can do a DB PR CLS, and that should get rid of our thing that put the thingy on the screen with a byte at the screen with the 4 pixels, and then change this to PRINK. PRAT. Right. And PRE. Right. Now, we needed to put a number, didn't we? Now, what we need to do is PR decade Q23 PR Dec 16. There's no basic equivalence of these, so I'm just using 23 and 24. Right. Now, DB that, 0, 24, PR Dec 8, PR Inc, 7 times 8 plus 0. PR Dec 8, and then we need to do on the next line a DW and then test 8-bit value, and then we need to copy that line and paste, and copy that line and paste, and then test 16-bit value. Right, so has everyone got what I've just typed in there? I'll just leave it on here a sec so you can see the modifications and catch up. So it's the PR at 0,24 inc, PR inc 7 times 8 plus 0, PR decade. So you're using the emulator rather than native next to make full use of memory. Odin doesn't need to load into next memory. The Odin, if it crashes, it will crash. If it could like wipe out what's in the source file, it could. I don't know. It depends on what it does, because when you start doing things like a stack print, you're telling the when it returns from the values, it doesn't just there's no instruction. You don't know where the instructions start, or the CPU doesn't know where the next instruction starts, because it's using these bytecodes for the print routine. So you're then executing instructions that could be an issue. And whether you use an emulator or CSpect, you should get roughly the same effects. It'll crash and cause issues. So you need to either reset your machine, because when you assemble it, it saves the file anyway. So if you just reset machine and then load Odin up again, or reset CSpect, not your machine if you're using a PC, obviously, or a Mac, or Linux for that matter. And then so reset CSpect or restart your machine, load up Odin again, and load up your file, and it should be okay. Shouldn't be anything wrong with it. But it's just as a precaution in case anything has gone awry. So if you do have a crash when you write it and when you're testing, just don't go back in like I did initially before. Don't go back in and reassemble again, because that will save. And if there's anything corrupted in the file, it will save what the corruption is as well. So if you ever get something that doesn't run how you expect it to, just exit CSpect or restart your next. Right, so is everyone up to where we are with this print DEC 8 and DEC 16? Is anyone not up to date? I should say, rather than waiting for everyone to say yes. Someone please reply with I'm up to date, but as long as no one replies I'm not up to date. Right, okay, up to date. Right, okay. 23 and 24 definitions, yeah. 23 is DEC 8 and 24 is PR DEC 16. Right, so now that you've got them, we need to go down to our print routine. And then what we can do then is we haven't got a not CLS. Right, not CLS and then our usual jump to print, because we've got no more to add, but we have got more to add because we're going to now do CP PR deck 8 JR NZ, not deck 8. Load a brackets HL HL push HL or actually I want to do load L A load H 0 call deck 8 deck 16. Actually print deck 100. That's the 100 is the largest digit you can go to with the thingy. Right. Then pop HL and jump print, and then not deck 8 CP PR deck 16 JR NZ comma not deck hang on, I missed a bit out. Not deck 16 because we're getting an address, so we need to do load C comma C comma bracket HL load inc HL load B comma bracket HL inc HL push HL. Then we need to do load. Actually, we can do bracket BC, and we don't need that line or that line. Right. Yeah, that should be right. So, just to, because I've been messing about and re-editing it, it's CP PR deck 8 JR NZ comma not deck 8 load C comma HL contents HL inc HL load B comma contents at HL inc HL push HL load A comma contents BC load L comma A load H 0 call print deck 100 pop HL jump print, and then the not deck 8 we've got CP PR deck 16 JR NZ not deck 16. Let's just add in the not deck 16 here, and then add the jump print. That basically, if it just catches any of the other values, like so, if it just goes back to print, so it just skips it if it's got a value that it doesn't recognize. I'll show you in the data in a sec. Right, so it doesn't fall through into anything else. So we want load C comma bracket HL, and then I'll also go through what this is doing, because what we're doing is we're getting a pointer HL to our address for the registers of the values that we want to print. Load A comma bracket BC load L comma A load inc BC load A bracket BC, load H, A, call print deck 10,000, because the highest number is 65535, and pop HL and jump print. Right, now I can do it here. Print deck 10,000 HL equals number to print, DE equals position, but we've already got DE because we're inside the print routine already, and that's it. So we do print deck 10,000. Load tab shift A, BC, comma 10.123. Call penalty deck 0, deck 1. Oh. Deck 1. Load BC, comma 10,000. Call deck 1. Load BC, comma. Basically, what this will do is print digits for HL. Well, print one digit. Print deck 1. Let's see. Deck 1 just prints whatever HL is divided by BC. BC, comma 10, and then call deck 1, and then load BC 1. Although I can just do a load with L there. We need our print deck 100 here. I suppose I could do them all here. Print deck 1000. Print deck 10. A, comma L, JR, not right. Then put deck 1 is, I'm getting a shit ton of messages. You lost the picture again, black screen. Oh, okay, hold on, yeah. Thank you for all your messages. There you go to OBS. There you go. Where's my phone? Yeah, screen gone blank. Lots of messages, thank you. Yep, it's coding, but not as we know it. Yeah, I need to get rid of them other scenes because I accidentally pressed them. That one, right? Let me just remove that scene. Remove. Yeah, and remove just me. And back to that one. It should stay on that forever now, no matter whether I press Control 1 or Control Shift 1. That's when I was trying to find the edit. So, where are you up to? Put some money in the lucky. Takes me back. Right, where are you guys up to? Yeah. Right, come on guys, are you still with me? Wait for the feed to come through. Where were you up to before it went black? All right, first PR deck bit. Right, so you can still see it on the screen. So we're up to PR deck 10,000. Yep, cool. Right, so it's load BC with 10,000 called PR deck 1. Load BC, PR deck 1,000, load BC with 1,000 called PR deck 1. PR deck 100, load BC with 100 called PR deck 1. PR deck 10, load BC with 10 called PR deck 1. Load A with L, GR PR deck 0. And then PR deck 1, which is where we're up to. Yep. Did you hear anything? Did you hear me saying I've got a ton of messages? Even though you couldn't see anything. Anyway, I'm glad you're back with me. And that shouldn't happen again because I've got rid of the other scenes. I don't need the scenes in OBS. I don't use them. I just use this. I just stream whatever's on the second screen. Okay, good. Glad you were following them. So, should be able to continue now. So, load A, -1 or 255. -1 because we're going to do very next instruction, PRT deck L, which is our deck loop, is inc A. Then or A, which clears the carry, and then SBC HL, comma BC, and then JR NC, comma deck L. Then we want to add, because we've gone less than 0 with HL, we need to add BC back to it. And then PR deck 0, we want to load, it's already in A. We want to just do we need call PRT CHAR and then ret. And that should be it. Right, did we do the BC? Because we've got it in a pointer. Let's go up to our code. We need to also set up yeah, the reason I do it, the test 8-bit and test 16-bit value on a separate line is because it needs to be a DW because it's a word, because it's a pointer to an address in RAM. Say again. Test 8-bit value and test 16-bit value. Right. And we can do, at the end of our game loop, test 8-bit value, DB0, test 16-bit value, DW0. Right, and what we can do in our game loop, we can do load HL comma bracket xpos. Actually, h comma 0 because we don't need to. Actually, if we add HL comma 32, that'll be the position of our sprite, and that goes. That is a 16-bit value number. So then we can load. Sorry, I need to do load h comma 0 because it's only an 8-bit value for xpos. Otherwise, we'll get some random values. And load test 16-bit value close comma HL. Nope. And then load a comma pause. Load bracket test 8-bit value close comma A. Right, save that, and then should be able to assemble. Should be able to send 238 line 238. Oh, wrong way. Comma. Not full stop, it's comma. And that's the only thing that's gone wrong. Line 238 was a comma. How many years it takes to memorize them? Not that long. There's not an awful lot to them. It's just you do things with different registers, like IncHL, IncBC, IncA, IncC, IncB. It's the same with all computer languages, really, with all processor languages. They usually just have pointers to memory. You have data registers that can do things like do the stuff that you do with the accumulator, where you can do maths on the registers, and then you can store them in store registers in memory, or you can move registers to another register or things like that. And you'll find that if you go with the fact of how basic and simple CPU, machine code language is, you then can take what you've learned from this, moving across to like 6502 or 68000 or whatever, because it's basically just knowing what the registers are. Like in 68000, you've got A0 to A7, which is the address registers, which are like your HL, BC, DE. And then you've got your data registers, which is D0 to D7, which are all like the A register. So you can add D5, D7 or whatever. But again, it's all you're doing is getting a number from memory in RAM and then doing something with it and putting it either back in the same place or putting it somewhere else. And that's how simple you'll find the instruction set is. And pretty much all of them. And some will have extra things specific to the machine, like the next has our pixel address and throttle down and add BC and add HL, offset. So yeah, the instructions are, because it looks like there's a lot, but there actually isn't if you separate it out into the groups of registers and stuff. You got it now. Okay. Right. So if we save that and X out, it helps if I'm in the right program. Yep, C-spec. Assembled OK, and then run it. And we haven't got that. I know why. And I need to do what I said before, and that's to exit out, because it didn't run as expected. I need to launch C-spec again. And drag it across to the screen. Control F1. Dot Odin load plot test. Yes. Right. I know exactly what it is. It's in our print deck, and it's printing. Actually, it shouldn't have crashed because I'm not calling the print routines. It's calling the print decimal, not print character. But what it is it needs to do a comma quote 0, and then call. You're gonna have to fix that, Mike. Right, so save that, and then, because that was why it was random characters, so if we exit that to A, 938, it will be this, no, 938. I somehow accidentally put right, let's exit out again. Odin load plot test .ods. Probably corrupted the bloody file, haven't I? Although it shouldn't have done, because I didn't save it after. Right, PR deck 16, EQ 24. Save. unless let me just see if the file has got too big, because I remember Matt was saying that it could be an issue. There's 10K. Unless he has extra stuff in there. In that bank, I don't know. 31 PRAF. Weird. Actually, that should be on a different line anyway, because that would write over the same, but that's a totally different issue. That's not the cause of it. 937. Well, that's weird. If I copy that and then delete all three of them, save. Line 34. Yeah, I think that's an issue for Matt to look at, because it's coming up with line 34, which is BR Inc 16, and there's nothing wrong there. So I'm thinking that because of all the comments in the code, it's gone over the size of a bank that we need to do. So what I'm going to suggest is, as he's not here at the moment, we shall call that a day. Actually, I'll put in the comments ready for next week. Let h equals 0 and h now comes 32 and depoke test 16-bit value, comma hl. Let a equal y pos y pos. Poke test value, comma a. Yeah, this is definitely for Matt to debug in the next 2 weeks. Me and Matt will sort it in the next 2 weeks, and then we'll put a link in the. Or we can go through the fix next week. But when he's fixed it, if he's fixed it before next Sunday, I'll do a quick Sunday video. If not, I'll do it at the start of the next video. Or I might just do it at the start of the next video anyway. It'll only be a quick fix. Oh, yeah. What else we got? If a. Actually, I suppose if we're getting close to the capacity of RAM, probably not put any more comments in for now until we fix it with Matt. Anyway, we did have it working, but not quite. I think maybe could it be a 2K, an 8K page that he's got it set to, not a 16K? Could be that, and it's gone over because we've added quite a bit of comments and stuff for the printing. Stuart Guest, right? Where's the is it down here? Yeah. Is it that then? I can't see it being this, but we'll try it. Control 7, if you're wondering what the thing is for that. No, it's still the same. It's not that. Yeah, it's probably just the sheer amount of code we've added. It's taken it up to over 8K. I think we were close to 8K before when it worked last, I think, maybe. No, because the print worked, didn't it? We only added that add 8,0. Although we did add a load of comments. 48. Yes, it's one for Matt to fix. Well done, Stuart. Cheers. Yeah. One for Matt to fix. Right, so that should run now. There we go. And why have we not got... I know why. Because we're only doing it in the loop, before the loop. Right. I can't block mark this, so what I'm going to have to do is yeah, you can get rid of this old code because we don't need that anymore, because I was just putting a value on the screen. And we don't need this CLS because it automatically does that. So if I copy that and paste it there, get rid of that, copy that, paste it there, get rid of that, and then that should print the thing every frame. Right, so if I then shift 1, assemble, and run, there you go. We can now print numbers. Yeah, Matt's sorting some family stuff out. So he apologised for not being here this week, but we've managed to sort it out anyway. Thanks to Stuart Guest, well done. Big brownie point to you, bud. So anyway, as it's like nearly 10 to 5, I think we can finish on that win. I will do the usual with the code. Actually, what I will do is make sure it's all commented. D equal D peak brackets x plus 2. Let's, this was last week, wasn't it? D equals 0 and D comma 32. Let A equal peak bracket y plus 2. Add A comma 32. Let L equal A. Let C equal naught. Let B equal naught. Let H equal naught. Go sub and right. Yeah. Not equal deck 8 and go to not deck 8. Yeah, who needs math? We do, because we need them to fix it for 2 weeks. Add the include. Let's C equal peak bracket HL. Let's HL equal HL plus 1. Let's B equal peak HL. Let's HL equal HL plus 1. Store HL on the stack. Let's A equal peak bracket BC. Let's L equal A. Let's H equals 0. And I'm going to try in the next 2 weeks to set up the next and get it so I can stream from the next, and then we can start typing on the next directly, which should be a whole lot better. Well, not that it'll be any different for you guys, but it might be different. I don't know. It'll be a next screen rather than a CSpec screen. Hey, Retro Engine, just about to finish. But as always, you'll be able to catch up with the video. And go to print. Equal PR deck 16. let C equal content peak HL. Let HL equal HL plus 1. Right. Even though I keep doing these, and I will keep doing these, I'm hoping that because I keep doing these, that you guys are actually learning to understand what the instructions are actually doing, and hopefully at some point we'll get this code big enough. We'll get this code big enough with the includes and stuff, so you'll be able to have like enough knowledge and routines built up to be able to start modifying this yourself and adding more bits. What I want to do next week is, obviously once we fix the issue with the quotes, once we fix that issue, I will, and assuming that Matt has fixed the include, then hopefully what we can do is get some handling routines in for the sprites so we can add more baddies and stuff, and possibly add like a start of this game. And yeah, cool. I'm glad you're enjoying the basic on the right, because it does help, and I will keep doing it because the more I repeat this, the more it will sink in on what is actually going on in the instructions. Right. Can I just ask the viewers one question? As you can see, I'm doing this let A equal peak BC, and then let L equal A, and then let BC equal BC plus 1, and let A equal peak BC again, and then this time I'm doing let H equal A. Can someone tell me what that is, what we're actually doing there? In these 5 instructions, the load A with BC, load L with A, inc BC, load A with BC, load H with A. Yep, exactly, Richard. Which is again is why I'm doing this. So I forgot to add in Q2 not deck 16. It reads the BC. Yes, what it's doing is these 5 instructions are basically let HL equal D peak bracket BC. That's where it's at. But you have to use A because you can only get 1 byte at a time from the contents of BC. So it gets a 16-bit value from BC. The inc BC points to the next byte, which is the high byte of where BC was. And BC was got from the address after the PR deck 16. So it gets BC, gets the address of the pointer, which points to our test byte, and then this bit reads the test word, test 16-bit value. And no more codes. Go back to print. Actually, this is sort of, well, it is go to print, but it's actually legal codes go back to print. Basically, what we can do is if we put a value in here, this can be like PR at what is that 0, 48, and it's changed in color. Hello, and then we will also have comma 5 space world. Right, that 5 is an illegal code because there is no instruction for 5 and there is no code for 5, but we should be able to see there's no, we had one space, which is exactly the one space that's there, but it doesn't crash or anything because we've told it to do that jump to thingy when it goes to not x16. So if it gets to here, it means it doesn't know what that instruction is that it's found, which is the row 5 that we put in the data. So it just goes back, so it stops it doing anything that we don't know it's going to do. Hopefully, but I'll take that back out because we don't need that 5 in there. Right, save that. Yep, Retro Robbins, no worries. I'm just going to go. I'm going to go through now and do the scroll down a bit, wait, and so people can see the whole of the source. And wait a couple of seconds, and do it again. Wait a couple of seconds. I'll catch you in 2 weeks, as always. Anyone not got up to where we are with the code, then you can use this to fix what bits you've not done. Again, I'll wait a couple of seconds. Wait here a couple of seconds, because you can just pause it when you're playing it back. See, Retro Robbins. Quotes are still broken. Is it just the quote on the load a comma quote? Richard, if it is, you have to take it to load a comma 48. Where it has the load a comma quote 0. A change didn't fix it. That's weird. What is the error, and is it still the same line? I'm I'm still pausing I'm going all the way through the code, so we'll eventually get to it. Just going through and pausing so everyone can use this as a way to get through to check your code with my code. To be able to pause it and check your code, and then scroll down a bit, pause it, check your code. Yeah, check against the listing later. If you check with the listing and it's still wrong, then give me a shout, Richard, and I'll give you a hand trying to sort it. Changing EQ values around 32 to hex. Move the error. All right. Yeah, we'll find what the issue is. Yeah, you usually do. It's just a case of finding what the you'll probably find it anyway. You know, when you go through my code and your code, and you'll see what it is, see what the issue, what the difference is. I'm hoping it isn't the file size. I'm hoping it is a 16. I think he did say it was 16K banks, so it could be because we're at like 10K with the file size now, so I don't think that'll be an issue. Obviously, because it assembles on mine and pretty much everyone else's. Is anyone else having issues with it? Yeah. Hopefully, it's just something you've done, Rich. But it will be a bug from Matt, I think, because that load A comma quote didn't like that, did it? Right, nearly finished. And that's it. There we go. It threw its toys out of the pram. Definitely. Right, guys. Thanks for joining. Hopefully everyone else is up to date and working and not having the issue anymore. Hopefully it's just Richard. I should. I'll comment them in at some point. I'll do it later. I'll do it next week, or when we come to separate the files. Hopefully, Matt will have the include for next week, and then we can separate. Basically, what we'll do is we'll load the file in, and we'll separate each the bits out into separate bits, and then we can have multiple files, and then we can include them, and hopefully won't have any issues with the memory being too big for the file. See you in a fortnight. Anyone got any questions about today's episode? And then just go back to line 26 so you can see what mine is. Yep, no worries, Gamer Eyes. I was going to show the colours at some point anyway. There's still a few things we need to do in the codes, like I want to put a pause in there so you can actually do some menu screens like start game, press any key to start, and it'll just have a value to wait for a key press and stuff. Right, what line was it? 20. Oh, you're going higher then, Rich. Where is it? What was the line that you said? A 26. Oh, it's identical, is it? Yeah. DMA disable 83. Yep. So it's probably somewhere else in the code because that DB was DB the load, not DB, the load 8 comma quote. Where is it? Because it was definitely this one for me causing the issue. So anyway, Richard, just check at some point when you can over the next 2 weeks, and if showed us 32 and it wasn't there, okay. Which quote 0 showed us 32? Anyway, I say over the next 2 weeks, whenever you got time to do it, just have a look, see if you can find out, go through the source line for line, find out where the issue is, and let me know how you get on with that. Hopefully it's all okay, and I'll see you all in 2 weeks. Glad you enjoyed the today's episode. Okay, no worries. Catch you all soon. Hugs to Crowley too. See you, Mike. See you, Gamer Eyes. See you, Stuart. No worries, and thank you. Right. Let's see if I can get my mouse back. Yeah. Right. Bye bye.